Alright, today we are going to use our unit circle, no calculator, to solve different things. And you can see what the unit circle is useful for. So the first thing we want to do is convert between radians and degrees. Degrees is the one that we usually memorize. Radians is the upper level math and calculus. That's what you want to do. So what we need to do with conversions is remember, like if you were doing feet and inches, you're actually multiplying it by the value of 1 to change the units. So for every 180 degrees is pi, or radians, okay? So what we're going to do is you take your degree and we're going to multiply it by the value of 1, which is 1 over the other here. If we want to get rid of degrees, our degrees have to be in the denominator and our radians in the top. Okay, so guys, this is the value of 1. Those degrees cancel, and we're left with 40 pi over 180. Now, of course, we're going to reduce this. Your zeros cancel, and 4 divided by 18 is 2. And don't forget the pi over 9. Okay, so now you can convert all of your degrees into radians. But yes, this is something you should have done last year. So if not, make sure you're practicing on this. Okay, reference angle. Reference angles, what they mean is that everything can be compared to the first quadrant. Okay. As you can see, the second quadrant is a reflection of this, where we have kind of a reflection over y equals negative x for the third quadrant, and the fourth quadrant is a reflection over the x-axis. Okay, so we're going to use that. So we're going to identify the reference angle. So in other words, we're saying at 135, what is the angle in quadrant 1 that we can compare this with? So 135 is right here, right? As you can see, how many degrees is that from 90? It is 45. Okay, so we want to ask ourselves, what can I do to get this to 45? If you look, we can take 180 minus our angle, and that gives us a 45 degree angle. So I see that 135 was in quadrant 2. So anytime you have anything in quadrant 2, we're going to take 180 and we're going to subtract the angle that we were given. So the reference angle is going to be 45 degrees. All right. 260. Well, 260 is in quadrant 3. Okay. Now, 260 is not on our unit circle, but I'm going to use a different one to show you what we need to do. So let's say 30. Okay. What is another 30 degree angle? 210, right? I told you it's the flipping over y equals negative x. Do you guys see that? Okay, so if this angle right here equals this angle, how would we get to that 30 degrees for doing 210? Well, if you look, it would be our degree minus 180, and it gives us our reference angle. So I'll repeat that. In quadrant 3, we're going to take our angle, which in this case is 260, minus 180, and that will give us our reference angle. So 260 minus 180 is 80. Okay. Next one, 310. That's talking about our fourth quadrant. So let's see what we would do for our fourth quadrant. Again, 310's not on there, so let's take something that we know. So remember that first quadrant and fourth quadrant is a reflection down. So this angle should equal this angle. So 330, but 360. So it's going to be 360 minus 330, and we get that reference angle. So for the fourth quadrant, you're going to take 360 minus our angle. So the reference angle for this one is 50. Okay, let me repeat that. Quadrant 2, we say 180 minus the angle. Quadrant 3, we take our angle minus 180. In quadrant 4, we take 360 minus our angle. We can do the same thing for radians, okay, except instead of using 180 and 360, we're going to use pi and 2 pi. So 7 pi over 4. Okay, we need to figure out what quadrant that's in. 7 pi over 4, as you can see, is in the fourth quadrant. So, what did we do with the fourth quadrant? We took 360 minus, but 360 in radians is going to be 2 pi. So 2 pi minus 7 pi over 4. With fractions, you know that you subtract doing common denominators. So I have 8 pi over 4 minus 7 pi over 4 gives us pi over 4. Alright, now let's look at E 3 pi over 5. I want you to notice that since it's not one of our major radians, we need to figure out where in the circle it would fall. Well, if you notice the patterns, in the second quadrant, the numerator is smaller than the denominator. Okay, that's the only quadrant where the numerator is smaller than the denominator. And we see here it is smaller than the denominator. So this is in quadrant 2. In quadrant 2, we took 180 minus our angle. So we're doing in radians, so it's going to be pi minus 3 pi over 5. Common denominator, 5 pi over 5 minus 3 pi over 5, giving us our answer of 2 pi over 5. Next is 9 pi over 7. So we need to figure out where that is. 9 pi over 7, well, the numerator is greater, so it's not quadrant 2. So this is what I look at. Let's look at the denominator. Over 7 would either be right over here or right over here. Okay? Now, out of those two spots, does it make sense to have 9 pi here or 9 pi here? As you can see, it's 5, 7, 11. 9? No. 4, 5, 7, 9? Yes. So it's in the third quadrant. In the third quadrant, we took our degree minus 180. So in this case, we're going to go 9 pi over 7 minus pi. So 9 pi over 7 minus 7 pi over 7, giving us 2 pi over 7. Now our notes want to see if you can remember the first quadrant. So what I would like you to do quickly is pause the video, and then when you fill that in yourself, start the video to see if you got it right. I'm just going to fill it in right now. So 0, 0, 1, 0, 30 degrees which is pi over 6, square root of 3 over 2, 1/2. This is 45, which is pi over 4. That's going to be square root of 2 over 2, square root of 2 over 2. The next degree is 60, which is pi over 3, 1/2, square root of 3 over 2. And this is 90 degrees, which is pi over 2. And that's 0, 1. If you know this quadrant, the rest of them are very easy to fill out. Alright, here's what we need to remember about the unit circle. Cosine are the x values. Sine are the y values. Now, if you remember from basic trig, tangent is sine over cosine. And now we can interpret that as our y value over our x value, excuse me. Alright, now that we know the values, we're going to use our unit circle to help us actually find the value at these degrees in radians. So sine of 135 degrees, we go to 135, and we found out that sine will be the y value. So our answer is the square root of 2 over 2. Get your unit circle. Find 5 pi over 4. So 5 pi over 4 is right here. Cosine is our x value. So it's negative square root of 2 over 2. Alright, tangent. So again, tangent is technically not on our unit circle, but we can make it show on our unit circle by saying sine of 7 pi over 6 all over cosine 7 pi over 6. So on your unit circle right now, find 7 pi over 6, and we're going to find the sine, which is the y value, and you should get negative 1/2. Then if you look at the cosine, you see it's negative square root of 3 over 2. But we need to simplify this because, one, you can't have a fraction within a fraction, and you also can't have a square root in the denominator. So these 2's cancel. We are left with 1 over square root of 3. Last year we learned how to get a square root out of the denominator, which was to be multiplying it by itself. But we know whatever we do to the bottom, we must do to the top. And this gives us square root of 3 over 3, since the square roots cancel. Alright, so what we're now going to do is look at where our trig functions are positive and negative. So don't forget, cosine is the x value, sine is the y value. So in each quadrant, we can tell right off the bat if it's going to be positive or negative. So cosine and sine in the first quadrant are both positive. In the second quadrant, cosine would be negative, but sine is positive. In the third quadrant, they are both negative. So think of it just like your XY plane. Cosine in the fourth quadrant would be positive, and sine would be negative. Alright, there aren't just 3 trig functions though, we gotta think of the 6. So I'm not too worried about the sine, cosine, and tangent because we just went over that. But we have to show it in relation with the other 3. So cosecant is the same as 1 over sine. Secant is the same as 1 over cosine. And I'm going to show tangent as 2 different things. So cotangent is 1 over cotangent, or 1 over tangent, sorry. And we know that tangent is sine over cosine. So that means that we can reflect that, and it comes out to be cosine over sine. So these 3 help us use our unit circle to help us solve for the other functions. So let's practice that now. Secant pi over 3. Secant is the same thing as 1 over cosine. So this is cosine pi over 3. Then on your unit circle, I want you to find cosine pi over 3. If you look at that, remember cosine pi over 3. Cosine's the first part of the coordinate, so that's 1/2. So now we have 1 over 1/2. When you have a numerator divided by a fraction, it's the same thing as multiplying by the reciprocal. So our answer is 2. So cotangent, and it's going to be easier to remember cosine over sine. So I'm going to rewrite that. So it's cosine 330 all over sine 330, which gives us, if you go to 330 right now, cosine is square root of 3 over 2, and sine is negative 1/2. So let's simplify that. The 2's cancel, leaving us with negative square root of 3. Now remember, I do not want square roots in the denominator, so you're going to have to simplify that further if we run into that situation. Okay, symmetry. Now, we can either memorize these formulas, or I'm also going to show you how to do it backwards. So what this paragraph is saying right now is if we were given cosine of a negative degree or radian, it would be the same value as if we were saying cosine of that degree. So example, if we were saying cosine negative 30, it would be the same thing as cosine 30. Whereas sine, if we say sine negative of a degree, then we would have negative sine of the degree. The other way to solve for this is to think about negative as going backwards. So when we talk about degrees or radians in general going forward, we go counterclockwise. So negative would be going clockwise. Okay. So the good thing about going clockwise is that you can see the reflection of that and look at the same pair. As you can see down here, you need to be careful with the positive negatives. So here we go. Using the symmetry, find the exact value of sine and cosine of negative pi over 3. So sine of negative pi over 3 and cosine of negative pi over 3. So if we were going backwards, I would say that pi over 3 is up here, right? Pi over 3. So negative pi over 3 is going to be that same amount of distance, but going the opposite way, which, as you can see, is a reflection of it. Sorry, my light is glaring with my unit circle. So all I have to do is find the degree and reflect it, and that would be the negative of it. So my cosine is 1/2, and my sine is negative square root of 3 over 2. You can choose which way you want to remember this. Now we know that formulas usually only last for so long, and then the process of going backwards might last longer. Alright, last thing. So in a circle, we can keep going around and around and around. So I'm going to show you the long way how to do this. There is a shorter way, but I want to give you your own opportunity to see if you can find that. When or if you think you find it, you can always ask me later. So 9 pi, sine of 9 pi. Well, if we remember, half a circle is pi. So 1 pi, 2 pi, 3 pi, 4 pi, 6 pi, sorry, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, and that's where we're at. Now remember, we wanted sine. Sine is the second part of the coordinate. So 9 pi equals 0. So just remember that sine 9 pi was in the same spot as sine pi. Okay. Now, cosine 31 pi over 6. Over 6 means that we're going every 30 degrees. Again, I'm going to do this the long way. There is a short way that you can figure out later. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So it's the same spot as 7 pi over 6. Which in that case is negative square root of 3 over 2. Have fun in trying to find the shortcut. But like I said, try it out, see what you come up with, and call me over.